Welcome to solverfy.
Okay, so problem number 56 wants us to calculate the rest mass, or the mass, of a neutral pion. And we're given the fact that a neutral pion is formed through the reaction of a minus pion plus a proton. So a minus pion and proton basically annihilating, colliding, and forms a neutral pion plus a neutron. And we're given the fact that basically the kinetic energy of the pion is 0, and that the kinetic energy when this collision happens and these products are created, the neutron is created with a kinetic energy. So kinetic energy of neutron is created with 0.60 MeV. So we want to calculate, so first, in order to calculate the mass of this, we need to know the energy of this. So we know a few things. So conservation of energy states that the energy on this side has to equal the energy on this side. So there can't be, they have to be the same. So we can use that to state the rest energy of the pion, since this side has 0 kinetic energy. So the rest energy of the pion plus the rest mass energy of the proton is going to be equal to the total energy of the neutral pion squared. Sorry, not squared. The total energy of the neutral pion plus the total energy of the neutron, which is going to be its rest mass, its rest energy, c squared, plus its kinetic energy. Okay, so yeah, when I say energy has to be conserved, I mean total energy. The total energy is conserved. So now we can rearrange this just to solve for the total energy of the pion. So the total energy of the pion is going to be equal to the rest energy of the minus pion squared plus the rest energy of the proton squared minus the rest mass energy of the neutron plus its kinetic energy. So the total energy of the neutron. So now we know all of these numbers, so we can plug this in. So we can say E pi, the total energy of the neutral pion is going to be equal to, it's going to be equal to, let's plug in these numbers, 100 and, equal to 139.6 MeV plus 938.3 MeV minus 938.6 MeV plus 0.60 MeV. Now this gives you a total energy of the pion, the neutral pion, of 137.7 MeV. All right, so now that we have the total energy of it, we need to calculate what portion is the rest mass energy. So because from the rest mass energy, then we can get the mass. So we have, from conservation of momentum, just like conservation of energy, the momentum on this side has to equal the momentum on that side. So, and since the momentum of the reactions is 0, since we say that they basically have no kinetic energy, that means that the total momentum of the products must be 0. But since the neutron has kinetic energy, we know that they have to have momentum, which basically means since momentum is a vector, that they just have to have equal and opposite momenta. So equal in magnitude, opposite in direction. So we can state that the momenta of the neutral pion is equal to the momentum of the neutron. Now, we can also state, we can multiply by C. Sorry, let me rewrite that. Neutral pion C squared is equal to the neutron the momentum of the neutron times c squared. So this is just the kinetic energy. So we can make that statement too, and using the form of the total energy is equal to P plus m0 c squared squared. And then we can rearrange this and state that PC squared is equal to E squared minus m0 c squared squared. Okay, so now we can plug that in to both these sides and state, and we now have the total energy of the pion squared minus its rest mass energy. Sorry, let me see here. M pi neutral c squared squared is going to be equal to the total energy of the proton squared minus its rest mass energy, c squared squared. All right, so now we can rearrange this and solve for the rest mass of the pion. So we can say m pi, the neutral pion, the mass neutral pion squared times c to the fourth is equal to the energy of the neutral pion, the total energy squared, minus the total energy of the neutron squared, plus the rest mass of the neutron squared. So now we can then say m pi 0 c squared is equal to the square root of that, e pi 0 squared minus total energy of the neutron squared plus its rest mass energy squared. Now we have all of these numbers because we solved for this here. So that's this number. And then this number here is just going to be, so the total energy is going to be the rest mass plus its kinetic energy plus its kinetic energy squared. So we can plug all these numbers in. So we can, so we get the square root of 137.7 MeV squared minus 939.6 MeV plus the kinetic energy, 0.60 MeV squared, plus the rest mass energy of the neutron, which is 939.6 MeV squared. And we work through all of this, and we come up with the rest mass energy. M pi c squared is equal to 133.5 MeV, or the mass of the neutral pion is just equal to 133.5 MeV per c squared. And there is your final answer.